Okay, now let's go on to question 3. So it says Usain Bolt broke the world record in 2009 by completing the 100-meter race. So this is the distance covered in 9.58 seconds. So this is the time. It was calculated that it generated a total of 81.58 kilojoules. Okay, so this is the amount of energy. But do take note, it is in kilojoules. Okay, in kilojoules. Calculate the total power generated. So power, we know the formula is energy divided by time. The time we have here, 9.58, so divided by 9.58. Energy here we have 81.58, 81.58. But because it is in kilojoules, we need to multiply it by 1,000. So what we're going to have here, power equals to 81580 divided by 9.58. So 81580 divided by 9.58. What you're going to get is 8515.657 watts. Okay, so final answer 2 or 3SF. Let's leave it to 3SF. What I'm going to have is 8520 watts. Now they say if all the energy generated was converted into kinetic energy, calculate the average speed achieved by Usain Bolt. Okay, so I want to find the average speed. They're saying all the energy is KE. So 8158 kilojoules is all KE. So I know formula first, KE equals to half mv squared. If I use this formula, you realize, oh, you can find speed. So the total, imagine all the energy becomes kinetic energy. So it will be 81580. That's the amount of kinetic energy you have, times half. His mass is 94 kg. Then we need to find his average speed. So 81580 divided by half times 94. This will be equivalent to v squared. So v will be equals to square root of 81580 divided by half times 94. Okay, square root of the whole thing. So if you press a calculator, okay, this one I need to really go and press a bit. So give me some time. 81580 divided by half. Okay, divided by 94. Okay, then what I'm going to do is I'm going to square root the answer. Okay, I'm going to square root the answer. So give me some time. My calculator a bit slower. Okay, so I'm gonna have a 40. So my calculated time is 41.662 meter per second. So this will be 41.6. Okay, 3 second configure meter per second. Now by comparing the kinetic, so this is part B answer. Part C says by comparing the kinetic energy possessed by Usain Bolt in real life and the answer in part A, calculate the energy lost to overcome air resistance. Okay, so this is the part where it's a little bit more difficult. Okay, so I need to first calculate his kinetic energy in real life. Okay, that I can compare it. So let's find the KE in real life. So KE equals to half mv squared. Now question is, what is his speed in real life? So let's find his speed first. So speed, we know is equals to distance divided by time. I know he finished 100 meters in 9.58 seconds. So 100 divided by 9.58, what you're going to get is 10.4 meter per second. So if I use KE, I find half times 94, that's his mass, times the average speed here, 10.4 in real life, squared. Okay, so let's press my calculator. Half times 94 times 10.4 square. Okay, what I'm going to get is 5,083.52 joules. Now, what is energy lost? It will just be energy lost will be equals to 81580, because that's the amount of energy he has generated or exerted, minus 5083.52, because this is his real life kinetic energy. Okay, so this equals to like that. So 81580 minus 5083.52. What I'm going to get is 76496.48. So if you round off the 3 significant figure, it will be 76500 joules. Okay, so this is the energy lost. Question is, why is all this energy lost? Definitely it must have gone somewhere. So as you're running, what do you always feel? You always feel like the air is pushing you back. So all this energy loss is actually used to, imagine most of it is used to overcome air resistance. Okay? So in part D, they ask us calculate the average power required to overcome the air resistance and other forces during the race. So power we know is energy divided by time. And they ask us for the average power required to overcome the air resistance. So as we overcome, actually it's also equals to the energy lost. Okay, this is actually the amount of energy lost. The energy lost is because it's used to overcome all this air resistance and other forces. So we have 76500, that's energy needed to overcome. The time taken for the whole race is 9.58. You realize you keep writing this 9.58 figure. So the power calculator will be 76500 divided by 9.58. You're gonna get 7985.386. So you round off to three significant figure is 799 watts. Okay, so that's for question 3. Okay, that's the answer and the end for your worksheet.